95% means how many standard deviations? 2 standard deviations. Okay? So how is this calculated? So you actually don't even need to calculate it using the standard error, correct? We don't care about the y-intercept, we just care of the beta. So 1.01, say I round it off to 1.01, so the lower 95% is obtained with 1.01 minus 2 standard deviations, so 2 multiplied by 0.1933, 0.19. And the range of the beta will go from this to 1.01 plus 2 multiplied by 0.19. So this number, and you can do the math and check, 1.01 minus 2 times 0.19 should be equal to 0.625, and 1.01 plus 2.19 should be equal to 1.39. That is, we can say with 95% confidence that our beta is going to lie somewhere between 0.62 to 1.39. Understood? That's the interpretation of the confidence interval. And if this is 2 standard deviation, 95%. If it's 67% confidence intervals, then we simply do, it's 1 standard deviation, so minus 0.19 to 1.01 plus 0.19. Right, this is our 95, and this is our 67. Okay? So you did this, right, in the previous one? Confidence intervals, right? Statistics.
And stats.
You must have from the. This is like one of the basic things. Okay. Yeah.
Statistics.
Why are there 2 lower 95 and?
Yeah, they just repeat the when you do the data analysis, you can there is an option to change the confidence interval. So if you want a confidence interval of 67%, you can actually tell Excel to do that. So you can actually, I just kept all the defaults, that's what it gave me. It's not hard to calculate. Okay? So that's our confidence, interval. The next thing, so this is the range of the beta. The next thing is what portion of the firm's risk can be attributed to market factors and what portion to firm-specific factors. So remember, our R squared here is 0.2837. So that means 28.37%. So what is this regression telling us? The regression of, we have market data on the x-axis and we have stock data on the y-axis. So when we plot our regression line, remember, R squared measures the goodness of fit, correct? So R squared is basically telling us how much of the variability in our stock is coming from market factors. Okay? It's showing how well our data is, how well our regression line is fitted to the data. Okay? So it's telling us how much of the variability in the stock is coming from market factors, which means, what is the interpretation of that? That means 28.37% of the firm's risk can be explained by market factors, okay, or comes from market factors. How much is remaining? 100 minus 28.37%. Say I round this off to 30, just for easier calculation. If I round this off to 30, 100 minus 30, 70% can be, if 30% can be explained by market factors, the rest 70% is coming from where? Where would it come from? The company, excellent. Firm-specific factors. Okay? So, which means what? That if we invested in Bed Bath & Beyond, we can, or if we decided to include it in our portfolio, we can actually diversify 70% of the company's risk. Did you get it? Okay? 70% of the company's risk is diversifiable in a portfolio. Okay? What will matter? The 28.37%. And the return that will be offered by Bed Bath & Beyond will be at par with which risk? The 28% or the 30% or the 70%? The 30%, the market risk. Okay? So that is the interpretation of the R squared. Clear? Okay. So 37% of the risk in the firm comes from market sources, while the rest comes from firm-specific factors. Firm-specific risk is diversifiable and is therefore unrewarded. Okay? So if you had $10,000 today and you put all your money into Bed Bath stock, you are not going to be rewarded for the 70% risk. You're only going to be rewarded for the 28% of the market risk. Okay? And finally, what is the market's expected rate of return on the stock? Market's expected return, you're simply going to use the CAPM. Okay? So you're going to use the beta, the market risk premium that I've given you, the risk-free rate that I've given you, and for Bed Bath, that expected return is 8.59%.
So if you're trying to get a good return, you'd want a higher R-squared value. So if you research stocks and do that, whatever has the higher R-squared.
Yes.
Theoretically,
Yes.
you do a higher return.
Well, yeah. Theoretically, yes. Theoretically, yes. But there are like problems with R-squared in the sense that you can actually manipulate R-squared. R-squared can be manipulated. You can lower it or increase it by introducing more or less variables or something. But let's say we don't do any of that manipulation here. Yes, you're exactly right. You can do that. Okay. And coming back to our significance, right? Remember we said that for our y-intercept, right? Our t-stat or p-value was too large. It was not significant. But look at our beta. Okay. The t-stat is 5.22, and look at the p-value. Okay, it's 1.73 multiplied by 10 raised to the minus 6. So basically that's 0.000000173. Okay, so that means it's highly significant. Okay, so that means what is the null for the beta? The null is that the beta is simply equal to 1. That's no different from the market beta. Okay. And the alternate is that beta is not equal to 1. That's different from the market beta. But here, because the p-value is so small, we are able to reject the null. Okay? If we are rejecting the null, we are accepting the alternate hypothesis. That the beta of 1.01 is indeed different from the market beta. Okay? So for all of you, it's always the case, just because the range of our data is not too much, so we always tend to get the x variable is always significant, but the y-intercept is sometimes significant, sometimes not. Depending on the data that you have. Okay. It's actually good if you see it's not significant. It's actually good because then you're saying that your stock is actually following the CIPM, right? It's at par. Its returns are actually at par with the CIPM. Okay. Yeah.
Will you post this spreadsheet?
Yeah, it's already posted.
Oh, okay.
Yeah, it's already posted. Okay. All right, guys. Oh God.
Can we have the quiz take-home?
So we'll do
Quiz.
No.
Take home quiz.
Next week.